Welcome to this beautiful channel, folks. I'm going to do heights and distance problems, but now in this one, we would be involving circle geometry. Here, I'm trying to demonstrate that your work is very important. Knowledge of your work is very much important. Let's look at this question here. In the diagram below, DG is the diameter of the circle with radius R. DE and EF are chords. There's DE, there's EF, they are said to be chords. Such that DE is equals to EF, which is equals to R. Now, we are being told that the side DE is equals to side EF in triangle EFD. Each one of them is R. Now, it is said that DF or FD and FG connects. Now, with this information, we should be able to answer any question that they ask us. They go on to say, give the size of angle E in terms of theta. Folks, look at where angle E is. Angle E is in triangle DEF. I want to repeat this again. Your previous work is very much important. Now, if you look at the shape DEFG, you will see that all those points are on the circumference of the circle. And that shape is a quadrilateral, meaning that it is a cyclic quadrilateral. Now, when they say to us for 1 mark, we should determine the size of angle E in terms of theta, we should use that information. Now, if we look at my solution, I started by saying angle E plus angle G add up to 180. These are opposite angles of a cyclic quad, which are said to be supplementary. Angle E plus angle G add up to 180 degrees. Opposite angles of a cyclic quadrilateral are said to be supplementary. I therefore manipulated and substituted. I took G into the other side, it became negative. I substituted, therefore angle E in terms of theta is 180 minus theta. We get that 1 mark. Now we know that angle E is 180 degrees minus theta. The next question says, show that DF, show that this side is equals to R square root of 2 plus 2 cos theta, all under the root sign. Now, folks, look at this. Do you see that DF is the common side to triangle DEF and triangle DGF? Now, I hope that this says to you, common side is always important. Now, let's go and look for that particular side. Let's see what we know. First of all, we know this side we know this side, and we know the angle between the two sides. That means we are going to use cosine rule because we know side included angle and a side. If you look at this, I said in triangle EFD, let's go to triangle EFD, triangle EFD, because I know this side, I know the included angle, I know this side, I'm looking for this side, which I reminded myself of the fact that it is the common side. It would be df squared is equals to ef squared plus ed squared minus 2 times ef times ed cos of the included angle. I went on to substitute. Remember, ed and ef, each one of them was said to be r. Now, we substituted there. Simplify. 2r squared plus 2r squared multiplied by cos theta. Folks, never make a mistake of adding these two because you don't know the size of that angle. Meaning that this now becomes unknown to you. You can't add 2r squared plus 2r squared. Please never make that mistake. Now, moving on here, looking on what they want, we had to factorize by removing the common factor, which is r squared. I did that. Now, I now get df squared, which is equals to r squared multiplied by 2 plus 2 cos theta. And if you look at the question, they don't want df squared, they want df. Now, if I take the square root of both sides, I would get df. The square root of df squared is df. The square root of r squared multiplied by 2 plus 2 cos theta is r square root of 2 plus 2 cos theta. We have answered that question for 2 marks. Let's move on to the next question. Next question says, show that 2 sine squared theta is equals to 1 plus cos theta. Now, what do they want here? Remember, we have just determined this side. We know this side. We know this angle. And we know the size of this angle. Because DG is the diameter, it means in triangle DFG, angle F is 90 degrees. Remember, the diameter to a circle subtends a 90 degrees angle at any point on the circumference. Now, it means that here, I'm actually looking for this side. I know this side, I know this side, I know this angle. I'm actually looking for this side. The examiner was very clever here not to say to us, what is FG? Now, how did I attempt that? I started by saying sine G is equals to df divided by dg. Why am I saying that? Remember, I made mention of the fact that angle F is equals to 90 degrees because it is subtended by the diameter on the circumference, meaning that triangle DFG is a right-angled triangle. Now, I substituted. Angle G was theta, and DF is there. DF is there. It is R into root 2 plus 2 cos theta. R cancels R. Then I cross multiplied by 2 there, and I got 2 sine theta, which is equals to root 2 plus 2 cos theta. Now, if you look at the question, there is no root sign. Now, how did they get rid of the root sign? They did that by squaring both sides. If I square this and I square that, 2 sine theta squared would be 4 sine squared theta. Root 2 plus 2 cos theta all squared would be 2 plus 2 cos theta. I went on to simplify this, removed the common factor 2 and 2. I got 2 into 1 plus cos theta. I divided both sides by 2. 2 cancelled that 2 there. In 4 there are 2 2's. Now it is 2 sine squared theta, which is equals to 1 plus cos theta. Let's see what the examiner asked us to do. Exactly that. We've got it, folks, meaning that we have secured that 3 marks. Now, moving on, the examiner says to us, determine the size of theta, and be very careful that vervolgens means hence determine. Now, if you say to me, hence determine the size of angle theta, it means that I must use the answer that I got above. The hence says use that answer to answer the next question. Now, what I did was I took what I got there, wrote it there as it is, but in a standard form. Then if you look at my equation, I've got sine squared theta minus cos theta minus 1. There's absolutely nothing that I can do with cos theta. But sine squared theta, I can write it in terms of cos theta. And in that, it would be 1 minus cos squared theta multiplied by 2 minus cos theta minus 1, which is equals to 0. I removed the brackets by multiplying. It became 2 minus 2 cos squared theta minus cos theta minus 1. I therefore added the like terms. When you add the like terms, you get minus 2 cos squared theta minus cos theta plus 1, which is equals to 0. It is now a quadratic equation. Therefore, we need to factorize. But before that, if you want to, you can divide throughout by -1. I said if you want to. You divide throughout by -1, it becomes 2 cos squared theta plus cos theta minus 1, which is equals to 0. Therefore, factorize. When you factorize, you get 2 cos theta minus 1 into cos theta plus 1. Then now you write cos theta as the subject of the formula. Cos theta is equals to half, or cos theta is equals to -1. You must remember what you are looking for. You are actually looking for the size of theta, which is that angle. Looking at this angle, we can see that it is acute, not obtuse. That is, it is smaller than 90 degrees. Now remember, cos theta is negative when theta is greater than 90 degrees. Now, if you look at our two solutions, I've got cos theta, which is positive half. That means the angle would be smaller than 90 degrees. And I've got cos theta, which is equals to -1, sorry. That means the angle would be greater than 90 degrees. That is why I say here, this solution is not gonna be applicable in this situation because the angle is less than 90 degrees. I want you to understand the fact that they're not applicable is because of the size of the angle that I'm looking for. All right, meaning that theta would be equals to arc cos of half. And arc cos of half with your calculator would give you 60 degrees. Now it means that this angle is actually 60 degrees. We have answered the question. Now, again, just refreshing what we have done here. Know your Euclidean geometry, folks. Master that. I always say basic Euclidean geometry. Number 2, be careful of the common side. Use the triangle or the shape with most of the information to get the common side. Number 3, always watch for right-angled triangles because they will allow you to use your trigonometric ratios. Now, lastly, I always say now, master your mathematics. If you master your mathematics, you will therefore be able to do any question that they are asking you. Proficiency and procedural fluency are the most important things in mathematics that you can practice through previous question papers. Thank you so much, folks. Make sure that you subscribe for more and turn on your notifications.